Welcome, everybody. We're going to continue our work today in Unit 2, and we've reached, I think, the last playground in the unit, which is area 2.7, covering loops. And I do have the teacher's version of the book up on screen right now. And I don't know if you guys are looking here, but you can see that there's not a lot of stuff in here to cover. So what I am going to do is I am going to pull up the keynote on screen and just kind of cover some of the highlights of this and what I think is important before we go into the playground. There's a, if you guys are wondering, there is kind of a reason why, if you look at our course shell, right? So we're in Unit 2, and over the last month or so, we've been kind of pushing our way through all of these. And these playgrounds are a lot more involved than some of the ones that we've done before, right? Like in the first course, they were kind of like, oh, this is a constant, here's a loop, good luck, kind of thing. But here they really dug in a lot deeper. There's a reason why we kind of proceed in this fashion, though. And last week we went through classes and inheritance, kind of did a compare and contrast with structures. And there's a lot of similarities between the two. But it is important to note that Swift is an object-oriented programming language like Java or a lot of other major languages. And structures are kind of like, I'm just going to say this real politely, like classes and objects light or something like that. They have a very special purpose, but they're kind of unique to Swift, right? So there's other mechanisms in other languages that are similar, but nobody calls them structures, classes and objects and inheritance. This is terminology we see very regularly in other programming languages. And there are a lot of similarities between the two of these, right? A lot of similarities, except when you instantiate an object or create it, the way that it's created and handled in memory is different. And that's really kind of the thing. The other thing with these is you're creating what we call basically reference types. So you kind of are creating sort of in a way your own data types. It's really kind of the way I think of it. So you're creating complex objects which not only have properties and values, but also have capabilities, right, built into them. So that those are big takeaways. We then ramped up and looked at collections, and collections is really kind of a broad scope term, which really, in the most fundamental aspect of it, we think of collections as, what's a polite way of saying it? It's like you think of like an array, for example, right? Like or a list. But you do learn that there's various different forms of these, right? So for example, I can have an array of type string or int or double, but the truth is I can also have an array of arrays or an array of objects or an array of structures or an array of function. So this is why we call it collections, because we're grouping things together. What are we grouping together? Just about anything, right? The main data structures normally are arrays, lists, and dictionaries, right? Also, in some cases, we call them sets. So if you have like your Python background, you've heard these words before, right? And you always wonder, like, why do we call them lists in Python and arrays in every other language? And then you discover, wait, there's lists also in Java. It's all because of how memory is handled and how the objects are handled, and all the APIs and libraries that sit behind them to manipulate those objects. So another reason why we use collections is it allows us to process large amounts of data very quickly and efficiently using a minimal amount of commands, right? So this is basically the byproduct of people building programming structures and going, this is really inefficient. What's a better way to do it? And structures and classes and collections all fall into the category of like they're made to make coding easier. And if you go all the way up that thing and go up to functions, even that also is the same thing, right? It's a repeated block of code, and all of these are interrelated. Why then, like you don't think of like these seem like pretty high level concepts. Then why are loops following all of those concepts? Well, there's a reason. The reason is because loops are built not only just to repeat simple blocks of code, but when you put stuff into collections or classes or objects or structures or enums or whatever you do, it's aggregated information that's ordered somehow, right? Either with an index number or a key value pair or whatever. And then sometimes you just want to look at what's inside, or you want to process what's inside or store what's inside. That is a repetitive process. So loops are a really powerful tool to use with especially the three things that precede it. You know, in a number of different ways. So that's why that's last. So let's take a look here at some of the higher level concepts then. And basically, just a recollection here, this language supports two basic loop types, right? There's variances of each, but basically two basic loop types, the for loop and the while loop. If I'm to summarize, you know, the major difference between the two, a for loop, I always think of as a loop that is kind of like a predetermined run amount, like you kind of know how long you're going to run it, or your data dictates how long you're going to run it if it's automatic, where the while loop is more conditional, right? So in other words, usually you have to like trigger something true or false to even start the loop or end the loop, right? So you can do a while loop or do while loop is the other thing. In a basic for loop, and one of the ways that we're going to use that here when we run across like a collection or an array or a list or whatever is this, you know, basically what this is really truly I would call this a for each loop, because this one would run automatically and it would look at some sort of a structure that is indexed, like let's just think of an array, right? And then we would look at the index numbers, and this is basically a range command. It's saying we're going to run over the index value from position 1 to 5, and we're going to hit every position. And every time we hit a position, this is what we're going to do, right? And all this is going to do, because we're not really attaching it to a collection here, we're just running from the number 1 to 5. It's just going to output 1, 2, 3, 4, 5, right? That's the output. But we can predetermine its run. We don't have to check for true and false. We're just saying, just do this, you know? And if you think back to like, you know, if you were a Python student of mine, where I use like the cookie recipe as an example for like, you know, repeated code, you get to the point where you're putting the batter on the cookie sheet. How long do you keep putting the cookie batter on the cookie sheet? Well, until you run out of batter, right? So it's kind of automatic. You don't have to check for true and false, right? You just do it until it's gone. Right? That's kind of the point. Now, interestingly, you have this approach too, where now we're not using a name for the variable, and it's just a generic. So, and I forget what Apple calls this. I think they call it like a generic placeholder. So I'm not assigning a variable here because I'm not using it for output. What would this do? Well, this would print hello 1, 2, 3, 4, 5 times. It would loop 5 times and print hello 5 times. So that is kind of a new thing. This is kind of a weird thing. Why? Because it doesn't occupy memory. So this is the why. The other approach would. Now, when you start to look at this in combination with how it works with pre-built data structures, here's some of the power of the for loop. So here we have an array with 3 names in it. And then we set up our for loop and we say for each name, and you hear that how I said each in there, right? Because in other languages, when we do this and the loop runs automatically, it's usually a for each loop, which is different than a for loop, right? But here we don't have to use the each keyword. We just say, we set up a variable, which is used inside the for loop. And then we look at this structure of names, and this is a complex data structure now, right? So we're just going to say for each one of the entries is really what we're saying that's inside this structure, we're going to output the name. So this would output Joseph, Kathy, and Winston in that order. Now, so we don't forget, when we're working with strings are actually also complex data objects because they're a collection of individual characters. And then we've also learned that if we look at like the first character in a string, its index value is 0, and then 1, 2, 3, 4, 5, 6, right? So there's 7 characters here. And here, because this in and of itself is a complex data structure, we can iterate through each character and print each one out separately. Right? That's kind of the point. All right. And I'm not sure why the keynote is doing that, but it's doing it. Now, this is kind of weird because you can also kind of do this, and we haven't learned about the concept of enumeration yet. But this is a thing that we can add to the end of a thing. And what it does is it basically enumerates or lists two values. One is the value itself that's being stored, and the other one is the index position. So we're enumerating it. So in other words, we would go through and we would have, it would print 0, A, and then it would print 1, B, and 2, C, etc. Right? And then hopefully you sunk my battleship, bad joke. But you know, that concept, basically, the enumeration is we're numbering the complex object with an index value. The truth is it's already there, right? We're just utilizing that, but that's basically what an enumeration is. Now, the other structure that we have for collections that's weird is this dictionary structure. And a dictionary is kind of like an array. So you still see the square brackets, but we have what we call key value pairs, right? The first part in front of the, or to the left of the colon, is the key. So this is, instead of having an index number, in this case, we have text. That's what's indexing it, is that name. And then on the right side of the colon is the value that's stored. Now, this is kind of a weird one because it doesn't really matter what's in what position. Well, relative. So in other words, what I mean by that is your key could be a string, or it could be an integer, or it could be a double, or it could be something more complex. But typically it's one of those three things. But in this case, the value we're really storing is 1, 2, 3, and 4. The indexing is unicycle, bicycle, tricycle, and quad bike. Interesting, right? So if I were to look up quad bike in my collection, right, it would return the value of 4. Like, what's in position quad bike? Oh, 4, right? And we know that these are kind of pointing to the number of tires on the vehicle, but this is a dictionary, and the information is organized in key value pairs. This concept of key value pairs goes back a long time. And in other languages, like in PHP, for example, we call this an associative array. We're associating a key with a value. A really good example of a key value pair would be like if I had a table of information and I had columns for first name, last name, and address, for example, the column headers, first name, last name, and address, would be the key. And then the thing that's stored with each record. So in other words, each one of us would have a different key value pair for first name, right? We all have different first names. Each one of us would have a different key value pair for second name, right? So this is kind of reviewing the stuff that we just did. The point of this ultimately is, because there's a key value pair and we're traversing it with a for loop, you can actually use each one of those, right? So we're traversing using both, and we can output the contents of it. So if you have a dictionary that's a key value pair, this is a simple way to output it and see what's inside there. What are the keys? What are the values, right? The other reason why key value pairs are hugely important these days is there's this technology called JSON, JSON, which stands for JavaScript Object Notation, which is basically key value pairs, but instead of being inside of square brackets, it's usually inside of curly brackets because it's in JavaScript format, but it's become kind of like the #1 de facto way of transmitting data across the internet from one application to another. It's almost like the #1 tool now. Not the exclusive #1 tool. I mean, there's certainly other technologies are being used, but JSON has really made big inroads, and it's all key value pairs. And the advantage of a key value pair being transmitted as data is you have the definition of what 1, 2, 3, and 4 mean. If this is a regular array and it was just filled with 1, 2, 3, 4, maybe it was called like, bicycle tires, you'd have no idea what it meant. It's just numbers, right? Here, because the header or the column information, basically think of it that way, travels with the information, you know what the information means. So the information has meaning. This is why we call it a dictionary. What does this mean? Oh, I don't know. What's the key? That's what it is. Like you're looking it up in a dictionary and you're getting the definition. Right, so that's one example. Now there are also while loops, and while loops are ones where we do have to check a Boolean condition in order to execute the code. So in other words, before the loop starts, I usually typically set up a variable or constant, probably a variable, that is predetermined prior to hitting the loop. That variable is going to be checked to see if some condition is met. In this case, if it's greater than 0, right, then we would trigger a true. It is true, so then it would operate. So it does whatever it does, and then it, as you can tell by this one, number of lives, maybe every time you move, you lose a life or something, and it'll only execute until the condition is no longer true. The variable that we're evaluating, this is called the sentinel value or the loop control variable in some circles, right? But it's the value that we're watching to see if the loop keeps running. If you look at this example, how long would this loop run? So if you guys remember your loops at all, yeah, this would run forever.
Yeah.
Why? Why would this run forever? Because we're not doing anything inside the loop to change this value. This is set to be greater than 0. So this will infinitely print. I still have 3 lives. I still have 3 lives forever until you turn your computer off or kick out the power cord or the battery dies or something. So you got to watch that. So one of the challenges of doing a while loop is to set up criteria where you can exit out of the loop somehow. So that's what this is about. So in this case, now check it out. We start with 3 for number of lives. Now we're not using that to control the loop. Instead, we have a Boolean variable set to true, right? So the loop's going to run, right? Because it's already set to true. Notice we just need a Boolean result here, true or false. I don't have to have an equation. If I've preset it to true, it's going to run. All right. So what would it do each time? It would print out the number of lives. Then it would subtract 1 from the number of lives. And then if the number of lives reaches 0, then still alive gets set to false. So here we are changing this, but only when we run out of lives. And then we could exit out of the loop. So that's one of the challenges of setting up a while loop, is to make sure first you want to use that loop, make sure it triggers true so it runs. And secondly, have some way to get out of it, right? Because otherwise you run the risk of it running infinitely. And it's probably not what you want, ultimately. Now here they have a different kind of interesting thing. It's a couple new things that were thrown into the mix here. Here, if you look at this for loop and we're running a counter, right? This is a variable we use in the loop, and we're running it from -10 up to 10. So it's going to count up incrementally, one number at a time. So -10, -9, -8, all the way up to 10. And then it's going to print that out. And then when we reach 0, it'll pop out. So will it reach 10? No, it'll never reach 10, right? Because we throw this break command in. And what a break command does is it allows you to exit the loop. So that's another way to exit the loop. So instead of changing counter to exit, because in this case, because we have a counter in, normally this would run automatically until it reached 10. But here we have a criteria that if it reaches 0, we break out, so we can break out of this structure. That's kind of a technique. Right. All right. That's it. That's the lecture part. But it's a, it's a really good preview, honestly, of like what we're about to do. And that way, when we're working through these exercises, we can kind of remember some of that stuff. Hopefully it resonates a little bit with you. So I'm going to get the book off the screen here. And we are still working on unit 2. And the goal for today is at the very least to get through the loops playground, and we're going to try the apple pie project as well. All right, so here in my student files, I have opened up the loops playground, which you can see in the background here. I'll try to make this a little bit bigger. And I'm hoping this doesn't take super long time. There's 6 pages of stuff here. I'm also gonna bring my console up so we have both the console and the sidebar available to see output. And let's get started on the material here. So where we start here is it says create a for in loop that loops through values 1 to 100 and then prints each one of those values. All right, so this is pretty simple actually, so follow along here. Let's do a for, and then I need some sort of a number variable name. And in truth be told, you can call this anything you want, but a really common practice is to call it index. In a lot of languages, we just use the letter I, right? So if you ever wonder, like Jonathan, right now, you're in my Java class, we get like loops and stuff. And why do we use I? Because, well, I stands for index in mathematics. That's the why, right?
Yeah.
And if we're doing a separate loop control variable, we might use J. Why? Because it comes right after I, right? But here we're spelling out the whole word. So we're saying for index in and 1 ... 3 dots, right, to declare the range. For 1 to 100, we just want to simply print out where we're at with index. So we're just going to say print, and you can simply do this. You can add words to it if you want. Now, I think it's really interesting here that, you know, in the sidebar, it just says 100 times. Okay, well, what's 100 times? Okay, it tells us how many times it ran, but we don't really see it. You do have to go to the console to see the output, but you do see that it does do it, right? It didn't take very long either. So that's like a basic, what we call for in loop. So a for in loop runs automatically over a range that we predetermine. With the next one here, we have a string constant that's been created called alphabet, and guess what it has in it? The alphabet. And remembering that or strings are complex data structures, a collection of characters, we can therefore loop through the contents. And in this case, they want us to not only grab the letter and put it on the screen, but also the index value of its position, right? So if you remember from what we just did a few minutes ago, or looking at those slides, because we're going to be running 2 variables inside the loop, I'm declaring them inside parentheses, and one's going to be the index, and the other one's going to be the letter that we're encountering in the alphabet. Right. We're still going to do an in, so it's going to be a for in, and then what are we looking at? Well, the alphabet, right? That's what we called it. But if you remember also from the slide, in order for us to grab that index value, we use the enumerated function or method technically, which makes sure that they're numbered so that we can pull that value, right? And then after we've done that, all we just need is a print statement, so we can say print, and you know what, I'll just do it with string interpolation here, right? So we'll just say instead of quotes, backslash index, right? Maybe well, we can do a colon, I guess, in the space, and then we can do backslash letter. So right, and watch the output at the bottom. All right, and I'll pull the thing up. So what it did is it read all of the index values for each position in the string, put it on the screen, it enumerated it, right? And then we output the letter. But it was successfully able to go through, and we do have 26 letters. So it goes from 0 to 25, which is 26. Pretty interesting. All right. So that's a pretty basic one too. I'm assuming you guys are doing okay with this so far.
Mhm.
All right, so the next one says create a string array, right? So when you see the brackets here, right? We're creating an array, and this syntax here, this one's kind of a weird one, right? Because really what it's saying is we're creating an array, not an array, a dictionary of strings where there's going to be a string as the key and a string as the value. So we're doing key value pairs. This is going to be a dictionary, not really an array, right? And remember, the difference with the dictionary and array is with an array, we just put stuff in positions and the indexing takes care of where we're at. With a dictionary, the key determines where we're at. And just because we put stuff in here in a certain order doesn't mean its index position is the same. Doesn't mean they're going in the order that they're being put in. So this is kind of an interesting conception. Now, what they're saying is, okay, so the keys are the names of the states and the values are their capital. So the key value pair is state and capital, right? So if you were to go ahead and build something like this, you would do a let statement. So you would say, for example, states and capitals, yeah, capitals, not capitals. And then it will be a collection of some sort or complex data structure. Key is string and the value is string. Now, most of the examples that we've seen before from Apple have been like the keys have been text and the values have been numbers or vice versa. Here's an example of both of them being key value pairs. And I'm going to say that out in the field, this is probably the most common format. Then we need to actually build the structure. So here we go with square brackets, and then inside here, I'm just going to put the first one in as a copy paste here, but I'm just picking a state at random. Actually, I'm not. I'm stealing the author's, and he is Virginia, right? So in Virginia, the capital is Richmond. If you want, you could throw in, for example, one that you know, like Wisconsin, or hopefully you should know, right? If you live in Wisconsin. And then the value that goes with it, of course, is Madison, right? And the reason I throw in the Wisconsin one is like, oh, that's what you mean, right? Like people, they just get it more that way, right? When you bring it home. Now you can go through and you can do all 50 states if you want. I'm just going to grab the other two that the author did. And of course, you got those like weird ones. If you guys ever played that game as kids, right? Like what's the capital of Vermont? You know, that kind of thing. And that's the one that always stumps everybody. What is it?
Oh, I don't remember.
Yeah, answer right. I think it's Montpelier or something like that.
Oh,
Yeah, something weird, something weird like that, or maybe that's New Hampshire. I'm not even sure. So, but there it is. There's a key value pair. So key and value. So this is the lookup thing. This is really the stored item. Truth is, they're both stored, right? Yeah. All right. So now that we have that structure, how do we traverse it? Well, the for loop still. And in this case, we are going to be looking at both pieces of information. So one we're going to call state, right? Those are names for inside the loop. And the other one is capital with the AL. And that's going to be running over the structure of states and capitals. There's the curlies. And then we're just going to do output. We're just going to output, well, let's do an output statement that makes a little sense at least. We'll say the capital of string interpolation here of the state, which is the key, is, and then the capital, which it will look up the state, find the one that's associated and bring it back. And if you look at the list at the bottom here, you can see the capital of Wisconsin is indeed Madison, according to that list, right? So that would be the example for that one. Did that work out for you guys?
I'm
for
still
me.
typing it.
Yeah, I'll give you a second here. I will pause the video for just a moment while you guys are catching up. Seems like everybody's doing okay. Let's move on to the next page then. All right, and once again, of course, we're doing the fitness tracking app here. And suppose your app contains a list of different movements that can be tracked. You want to display each item in the list to the user. So they're saying use a for in loop to loop to the movements below and print each movement. All right, so this is just a matter of practice and repetition here. What's different about this approach is how we're doing it. With the previous page, we were doing structures over a numeric range or key value pairs out of a complex object. Here, we're going to declare a local loop variable called movement, and then we're automatically going to traverse the structure above, which is an array of strings, right? It's not key value pairs, it's just an array. And so for each movement in the movements, we're just going to print it. So it's going to do this. Print each individual movement, and you should see now, walking, running, swimming, cycling, skiing, and climbing. All right, so those we're able to read in there. But you see how simple that syntax is? Python is equally as simple, by the way. Some other languages, not so much, right? But this one is particularly simple. Now they say, now suppose your app uses a dictionary to keep track of your average heart rate during each of the movements in the objects. The keys correspond to the things up above, and the values correspond to the average heart rate your fitness tracker has monitored during the movement, right? Loop through the structure below, basically, and printing statements telling the user his or her average heart rate during each exercise. So here, in other words, we'll probably have a message set something like, your heart rate while walking is, your average heart rate while walking is 85. Your average while running is 120, etc. That's what we're looking to output. Notice the structure here, because this is a key value pair, the change in the definition here. So the one on the left is the key, that's a string. The one on the right is an integer. That's the value. And then to traverse this, right, we're going to put it inside parentheses, but we're going to call one of the variables movement, singular, comma, heart rate that goes with it. And then we're going to look at both pieces of information from the complex data structure movement heart rates above. Curly brackets. And then let's do some output here. And the author did it. The author said, your average heart rate when whatever the movement is, and then display the actual heart rate. There you go. And you can see down here at the bottom, it shows that it's reading the key, it's reading the value, it's putting both on the screen. But I mean, really, we know these are two separate pieces of information, but they are associated together, and we can use either piece of information in our program. Both the key and the value have value, right? So I think this is really helpful, very helpful. Sometimes you want to know where the data comes from. Sometimes you want to know the data. Sometimes you want to know both, right? Just depends on the situation. I'll assume you guys are okay.
Yep.
Yep.
Let's move on to the next. So now we'll start tinkering a little bit with while loops. And it says, create a while loop that simulates rolling a 6-sided dice repeatedly until a 1 is rolled. After each roll, print the value, and then they give you a hint here. Use the int.random in 1 to 6 generate random number. They tell you what the code is. So I'm not sure how much we've done this before with Swift, generating random numbers, but it is always a thing that you can look up for a language if you're not sure how to do it. One of the complexities I always have is that sometimes I bounce between so many different languages. I'm like, oh yeah, this is Java, we do it this way. Oh yeah, this is Swift, we do it this way, that kind of thing. But often the approaches are super, super similar. Now, what we're doing here is we're setting up a while loop. And notice the instruction was to keep rolling the dice until we roll a 1. Now, that might happen on the first throw, but it might not. We don't know, right? Now, before we start the loop, notice that I'm setting this loop control variable here, roll. I'm setting it before the loop. This is a really common thing with while loops, is to preset that loop control variable. We also call that the sentinel value or whatever, or whatever. It's the one that controls the loop. And we set it to 0 so that we know that this is not the case, so that the loop actually runs, right? So we set it before we go into the loop. When we're inside here, now we need to change the value of roll, because otherwise we may never exit, right? And we're going to do that randomly. We want to simulate throwing the dice. So we're going to say our current roll is, well, that int thing up above, so that int random. So we're going to say we need an integer that comes from the random function generator. And then there's an in command, and then we put in our range, and the syntax for our range is 1 to 6, because that's how a single die is got the numbers 1 through 6 on it. So every time it hits this code, it's going to generate a value between 1 and 6, right? And then, you know what? Let's output it so we know what it is, right? Because if it happens to print out a 1 and the loop doesn't work, well, that's a problem, right? So as long as the roll does not equal 1, it will keep rolling until it hits it. Now, the chances of this happening are 1 in 6, right? So it could end after 1 revolution through the loop, or it might take 50. We don't even know, right? Like sometimes you get unlucky, but normally within 6 rolls, you should probably hit it. That's what the law of averages tells us. And you know what? Notice what happened down here, right? It only ran twice before it hit it. If I run it again, well, look at this time. It took a while before it hit it. Right. So every time I hit that run button, it'll give me a different result. And I do recommend that you run it a few times. It seems like most of the time, it's happening in less than 6 rolls. And that makes sense, right? But every once in a while, and we haven't seen like a super long one yet, but every once in a while you should probably get one that's a little bit longer. Right? Here's one that's a little bit longer, right? But eventually you get it. All right. I think that's a nice little example, and kind of reinforces the random number thing, and also kind of using like kind of reverse Boolean logic to get it to run. This next little tidbit here, let's read through. It says, you may want your fitness app to help runners track and improve their cadence. Running cadence is the number of steps a runner takes in a minute. So to help with this, you decide to let the user input a cadence, after which your app will play a sound at each interval that they need to take another step. Oh, I see. Okay. So for this exercise, you will simulate a test run of the cadence feature of your app. So use a while loop to print take a step to the console 10 times. Once you've successfully printed take a step to the console 10 times, add the following code to the while loop. It says thread sleep for time interval. This will put a pause in between each iteration of the while loop, so the print statements actually occur at the proper cadence. So this is kind of interesting. And you know what? I don't know if I'm going to have the patience to wait you know, if it's a 60-second interval, I might not want to wait that long, but let's see where we're at here. All right, so how would we do this? So they have a constant already pre-created called cadence, and that's set to 180, right? The test steps is set to 0. And then we're going to use test steps to build our loop. So I'm going to do this. I'm going to say while the test steps are less than 10, because remember that was our target amount, right? What are we going to do? Well, we're going to take a step. So we'll print. What should we say? Take a step. Step. And then the test steps, we're going to increment that by 1. So we're adding 1 to it. Then we want to put in the line of code that they provided for us. And, you can actually copy it from here if you wish, right? Or from the teacher's version, or, gosh, you could even type it. Doesn't seem like it likes me copying from there. Let's try that one more time. I don't know if it deselected it, but is that what it's doing? Yeah, that's what it's doing. All right. So I have a different strategy here. I'm going to copy it from the teacher version as soon as my spinner stops spinning. Boy, that really, I want you to notice here, why is it spinning? Take a look at my sidebar.
Oh,
Yeah.
yeah. I think,
Yeah, 100,000 times. All right, let's see if we can get this to stop running here. All right, I might be in the force quit situation. Let's see. What is it? Command Option Escape, right?
Yeah.
All right, sorry, folks, force quitting. Welcome to the real world here. Problems.
The dangers of loops.
Right. And you know what? And I didn't even set up an infinite one, right?
Yeah.
But I'll tell you what, it sure did run a lot of times though. All right. So what I'm going to do here is I'm going to try to, so like right now in the background, it's trying to run and I need to get the correct code in here. And once again, I'm copying the code that you see in the paragraph above, and I'm grabbing it from the teacher's edition and just dropping it in. So here comes the paste. And we'll let that run. You can see that it's doing it. Now what, I don't know if you guys can see this in the Zoom.
Yeah, it's like glitching.
Yeah, it's trying to run, but every time it was taking each one of those 98,000 steps or whatever it was, it's pausing between each one of those. So that might run for like days, honestly, real frankly. All right. And I'm not really sure that this is a great addition, right? So here's what I'm going to do, at least temporarily. And this is, by the way, when we see this pop into computer code, that means we're running a separate thread, meaning a separate snippet of programming code in memory as an individual operation. So this is multi-threading technically, and we don't even know what that concept is yet. But it's something that happens on our computers all the time, right? It's the ability to run multiple programs simultaneously in separate memory spaces and not have them crash, right? To give you the appearance of multitasking. And I'm still, I'm thinking it's still doing it, right? And I'm not sure if there's maybe a wise way to scale this down. Like if I set this number lower, like to 10, would that help the code to execute faster? And I'm watching both up here and down here, but you see, watch the circle as it appears. And this is kind of interesting. It goes away, it comes back. So that's the cadence piece. So the cadence divided into this. So, so this is sleeping a lot less. But what was happening before was taking up basically a much longer time or shorter time. So I'm not sure if this is making it run longer or shorter. Now that I think about it, if I maybe did this, right, would that give me a smaller value? I'm still not getting it to output anything. I'm looking at my teacher's edition. That's not outputting anything either, by the way. Right. I don't think there's anything that we're doing wrong here, but okay. If we just kind of want to get some output on the screen, a very simple solution is just to do this, right? So this should output something. You can see I'm being very, very, so it's not even like doing the printout. So this is why it's a little bit frustrating. All right, I'm gonna try to run this again. The output on this is horrible, right? Yeah, and see their point on this is with that timer interval in there that basically if you were trying to run, it would be like step, 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 step. It would like tell you like how fast you need to go to hit that pace, right? You can see this is horribly failing. Now they're saying recreate the above example. So whether or not like this ends up kind of working or not, what we're going to do next is we're going to rebuild the while loop, but we're going to flip it and we're going to switch it to what we call, well, in most languages, we call it do while, right? Here we call it repeat while, because that's the syntax that we use. This was not in the keynote, right? So we start the statement with repeat, put in our programming code, take all the same steps we have here. So I'm going to grab all three of these steps, even though I got one commented out, but in principle, it shouldn't be. And then we check for true or false at the end with the keyword while. So same criteria, while the test steps are less than 10. But this time, okay, now the main difference between these two different kinds of loops is that this bottom loop, the repeat while, will run at least once and execute the code before it checks for true or false. Right? So if we want to make sure the code runs at least once, we can do that even if that's the only time it operates. Then we check for true or false at the end versus checking at the beginning and risking the possibility that it never runs, right? In this case, it'll run this code at least once, then check, and then kind of have us move forward. These are really weird examples, and I just keep watching the spinning wheels here, and this is like just not good, right? And really what it should do, right? And let's see if we can uncomment these and maybe, just maybe, get it to work. What it should do is it should go step, 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 something like that, but it's just not doing it. All right, I'm moving on. I still consider this a win. It's more like the while loop concept that's important than the actual output. All right, so now we're working on this next little piece here, and let's just take a look at this part. It says create a for in loop that will loop through an alphabet, which is C below. Inside the loop, print every other letter by continuing to the next iteration if you are on the letter you do not wish to print. So they have a little hint here. So they say you can use the is multiple of method on int to only print even indexed characters, right? So we've learned other ways to figure out if something's even or odd, but this is a method approach to figuring it out, which is kind of neat and useful at the same time. So let's build a loop. So we start with a for loop. We're going to be going to print every other letter. But we also need to not only look at the letters, but their index values too. So we're going to use parentheses here. So we're going to loop through both the index value and the letter, right, that are in the alphabet. And if you remember, we do the enumeration thing or enumerated thing to make sure that the positions are all numbered. Then inside the loop, we're just going to run an if statement. We're going to say if the index value, and then we'll use the method they gave us, is multiple of 2. So if it's a multiple of 2, it's even, basically. And the moment that that's not true, then we will jump out, right? So we won't do anything with it. We'll do a continue command. The continue allows us to basically move forward. And if you want like do a little like reading on that, of course, you can look that word up. So this does not, like the break command we saw before, right? This is not a break command. This is a basically like move on command, right? Or a break command pulls you out of the whole structure. The continue command says just move along. This is what it says basically. So what we're saying here, if, oh, and you see I'm missing a character there. So if that equals false, right? So if it's a multiple of true, 2 is false, which means if it's an odd number, just continue. What are we going to continue and do? Well, we're going to do a print statement, and we're just simply going to output inside here both the index value, right? We did this before, and we'll just put in a colon and a space, and then we'll output the letter, kind of like we did for the alphabet before. Now you should be able to see some output here, hopefully. And I'm not sure if my playground is still stuck from the last page. I think it's kind of what's going on. I'm going to hit the, yeah, I think I'm pretty well locked up. So guess what I'm going to do? I'm going to close the playground and reopen it. And if, okay, so now it's working because I am getting output. Yeah, but here's our raw output down here. So it does A, right? So if it hits a odd numbered letter, so you would think, okay, that would be an even number because it's the second number, but the index value is odd, right? So only stuff with even numbered indexes are appearing here. So that's A, C, E, G, I, K, M, O, Q, S, U, W, and Y. Keeping track. But it shows you at least that it's working. And that trick I just did, I just closed the playground and not all of Xcode. That might be a helpful thing to know too. Because what it did is it stopped that code on the previous page from executing. But now, of course, I am curious, right? If I go back to the previous page, will that code run?
I think it will.
Yeah, and see, now it's working. You guys catch that?
Yeah.
And what we're not seeing here, right? Like if I run the code again, but it shows you the cadence now is actually working. And you know what? I did mess with the cadence, right? So if I change that number, there you go. Step, 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 right? And really, like if you guys have ever used a tracking app for fitness, I mean, you do have apps that do that, right? So that you can get a running pace that's a good running pace for you. All right. There's the second part to this. So the second part says create a string dictionary. So key value pairs, where keys are the states, values are the capitals. We've done this before. All right. So I don't know if you guys remember, but since we have that somewhere, we don't have to recreate that from scratch. Where is that? Is that on the first page? Yeah. So we could come here and grab that. So if you want to save yourself a little typing, go back to the first page and just grab that. And mine does include Wisconsin because, hey, we're in Wisconsin. So if you're somewhere else, put your state in there. All right. And then it says have at least 3 key value pairs. We did that with one of them being your home state, like I knew in advance, right? Yes, I did know in advance. Now loop through this dictionary again, printing out the keys and the values in a sentence, but add an if statement that will check if the current iteration is your home state. If it is, print I found my home, and then break out of the loop. All right, so let's engineer this. So we're going to do a for loop on this one. We are going to have both state and capital basically printing out. So that's going to go inside parentheses. I'm going to do a local variable called state and a local variable called capital with an A. And then we're going to look at the structure states and capitals, right? The key value pairs, curly brackets. And then we'll just simply ask a question. Well, one thing we'll do for sure is we are going to print the state and the capital. That you could go back to that first, playground page, whatever you want to call it, and just grab that. So that's going to happen each time, right? But we also want to have if the state is equivalent to Wisconsin, and what will we do? We'll do a separate print thing and we'll say, I found my home. You know what? You should probably list it, right? So we should probably say, and maybe an exclamation at the end or something like that. Okay. And then we want to issue the break command, which pops us out of the loop and we process no more instructions. So whatever happens, the last thing that should be on the screen is I found my home, Wisconsin, and then it should finish. Now, here's what I find really interesting about dictionaries, and I want you guys to kind of play along with me here. And I think when we looked at this, was it last week or the week before, that we noticed that, like, if I go through this structure and output it, well, it outputs the letters in the correct order, right? Because they are indexed, right, numerically. A dictionary, however, doesn't operate like that, doesn't utilize memory the same way. In fact, it's free to put stuff wherever it fits, which now that's a really good thing in terms of memory efficiency, but a bad thing in terms of ordering. Because if I go ahead and just hit the run button here, what I want you to notice is when it runs, right, you would think that it would output Richmond, Virginia, and then it would hit Wisconsin and stop. But notice what it's doing. It's doing Utah. That's after Wisconsin. And then it does Virginia. And then it says, I found my home. And what you can't really tell from this is, like, really every time I run this, it's going to be different output. Because it's not traversing it systematically by the order that we created, because that's not how it's stored in memory. And every time I hit that run button, it's recreating the constant and storing it in a different spot in memory. Yeah, weird.
Interesting.
Yeah, it is very interesting. But it's all about data efficiency, right? So this is kind of an interesting data structure because it is not ordered sequentially. It's only ordered by the key, and the language or the engine behind, Swift is free to put that in whatever memory spot it wants. And then when it's time to read back the memory spots, then it does it in an order that makes sense to it. That's not the order that makes sense to us. But if I had basically all the states here, right? Like, and you can download lists of this stuff, by the way. And actually, this would be a great one for generative AI. Like, you could just say, hey, Chat GPT, generate a key value pair list of all the states, inside of square brackets, and boom, you would have it. In fact, that would be a fun one to try if you have access to the Surface, right? And and I think I mentioned this when I did my training, we would do exactly that. The instructor who has, a paid chat GPT account, he would, it's like, hey, let's get let's just not play with two states, let's play with all of them. And he would just ask chat GPT to generate the code, and then he would just paste it in. Right. So there's a good example of how it can speed up your professional work, but not interfere with the intellectual pursuit of it at the same time. All right. You guys all good with this one?
Yep.
Right. You want to experiment with it? Go ahead, add more states, or find a list of this stuff online. I'm sure it's out there. Now, we are on the last page of this. So when we do finish this, we are going to take a break. So let's take a look at this and what it says. We're going to go back to the fitness tracking app again, right? And that's a theme here, if you haven't figured that out. It says you decide you want your app's users to be able to put in a heart rate range that they would like to hit. And then you want the app to suggest movements where historically the user has reached that heart range. The dictionary that you see below, movement heart rates, contains keys corresponding to the movements it's tracked and the corresponding average heart rate for that user in the app, right? Historically, right? So, you would think that you have other aspects of your app that are generating those things, but every time the person's swimming, they monitor the heart rate and then, report back on it. All right. Now it says here, loop through movement heart rates below. And if the heart rate doesn't fall between the low heart rate or the high heart rates, these two values here, continue to the next movement heart rate. Otherwise, print, you could go blank. So in other words, it's going to show all the stuff. And then, if you're basically outside the range, it's going to give you an alternative activity, basically. All right, so let's write the loop on this. And we're going to say for. Once again, we're going to look at two pieces of information because it's key value pairs. So we're going to look at the movement relative to the heart rate. Right? These are variables I'm creating here locally for the loop. Right? What we're traversing is the movement heart rates array above, or dictionary, I should say, or associative array, if you will. And then we're going to check to see if the heart rate is less than the low heart rate, or I'm going to use the pipe command here for the or. So that's the shift of the backslash key. So logical or the heart rate is greater than the high heart rate. So in other words, if you're not like this exercise zone of heart rate, you got a problem. If you're too low or too high, it's going to suggest something else, right? So we're just going to use that continue command again. If the heart rate is too low or too high, continue. And then each time we go through, we are going to print. You could go blank. What they want us to put in there is a different movement. So in other words, we're checking each individual heart rate coming in. And if it's inside that range we've specified, so think about, like, if you look at the values, running will be in that range, skiing will be in that range, right? Everything else will be something else. So in other words, if I put in walking, it's going to go through and say you could go walking because your heart rate's outside that range, just for example. So so you could go running, you could go ski. Oh, I see. So it's getting the ones that are in the range. That's what it is. what this is really saying, okay, so let's backtrack that. So if I do put walking in here, which is 85, it hits this one, it's an or, so this is true, and it says continue. That means we go back to the top of the loop, but don't execute the code. That's what that means. Right. Now you could do this with an if else statement. It doesn't really matter how you engineer it. The other one is if it's above the range. So when swimming hits, it's above, it's an or, so only one has to be true. So it skips this and then goes on to the next one. But eventually it will hit one of these, right? The ones that are in range. Let's change those values if you want to test it, right? For a lower value, yeah, you can totally test it, tweak the numbers, but this is what you should be getting as an output. All right, finish this playground here. So let's wrap this video and we'll go to a break. So this video ends here.